Hi, today we're looking at Functional Skills Maths Level 1. We've got the AQA exam board. It's the November 2022 paper and we're going to start with the non-calculator section. Question 1. Circle the value of 6 squared. So 6 squared means 6 times itself. So we've got 6, 12, 18, 24, 30, 36. So it's got to be that one. Question 2. Write in digits 3,405. So I'm going to put a comma after there. 3,405. So we've got the 3,405. Question 3. Work out 60 minus 21 divided by 3. Well, you need to know your order of operations here, and that tells us that the division needs to be done before the subtraction. So we got the 21 divided by 3, and we can do that using our 3 times table. 3, 6, 9, 12, 15, 18, 21. So that's 7 times. So we can replace what was there with the 7. So 60 minus 7. And we could write this as a column, but actually we can just count back from 60. So 59, 58, 57, 56, 55, 54, 53. Okay. Question 4. Draw the lines of symmetry on this rectangle. Okay, so if we're drawing any lines, we want to use our ruler really. So we want a line that's going to split this shape into 2 equal parts with a sort of mirror image of each other. So we can do one straight down the middle. You don't have to measure it. So there, so you can see this and this is the same. This might be slightly bigger, but as I say, for the purpose of this, you don't need to measure it out. Is there another line that we could draw that would split this shape into 2 equal parts with a mirror image? Well, we could do it horizontally as well. Okay. Now, you might be thinking, what about diagonally? Well, if you imagine if you split it diagonally, if you folded the shape along the line, this corner would come over here. It wouldn't match directly with this one. So we've just got 2 lines of symmetry for the rectangle. Question 5. You are given that 8 times 7 equals 56. Use this information to work out 56 divided by 700. Okay, well, what we can do to start with is we've got times here and they've got division. Well, the opposite of division is times. So we can use this to say, well, 56, instead of 8 times 7 is 56. If we do 56 divided by 7, we're going to get 8. Right, now if we look at this one, instead of 56 we've got 560. So this is 10 times bigger. And instead of dividing by 70, we're dividing by 7. But again, to get from 7 to 70, you're dividing by 10 times bigger. So actually, and it might be easier, instead of dividing, if we write 56 divided by 7 like that, you can see if we multiply the top by 10 and the bottom by 10, actually they cancel out. So it's exactly the same. 560 divided by 70 is the same as 56 divided by 7. And then you can go through your 7 times table. So 7, 14, 21, 28, 35, 42, 49, 56. So that's 8 times. So just with a few questions already in this paper, hopefully you've seen how knowing your times tables and being able to do them relatively comfortably really helps with these papers. Question 6. Write these decimals in order, starting with the smallest. Okay, well, I'm going to write them one above the other. So 0.22, 0.202, 0.2, and 0.022. And to help me compare them, I want to have them to all have the same number of decimal places. So I can fill these in with zeros. I'm not changing the values because they're all at the end. And now, to make it even easier to compare, I can say, well, they're all 0 point something. So I can ignore that because it's the same for all of them. And just say, well, which is the smallest number? We've got 220, 202, 200, or just 22. Well, 22 is clearly the smallest. Then 200, then 202, then 220. Okay, so the smallest one was this one, which was 0.022. Second one was this one, which was actually 0.2. Then we had this one here, 0.202. And finally we had this one, which was given as 0.22. Question 7. Work out the range for these numbers. Well, the range is the biggest number minus the smallest number. Well, the biggest number is the 18 and the smallest is the 8. They've actually put them in order for us. They won't always be in order, so always look for the biggest number. It's not necessarily the one furthest on the right. Okay, and the smallest won't always be furthest on the left. But in this case, they are. So we want 18 minus 8. Well, 8 minus 8 is 0. 1 minus nothing is 1. So we've got 10. Okay. Question 8. Video blogging. Jude uses a social media app to upload videos. 8a. 1 week, Jude uploaded 30 videos to the app. The lengths of the videos were recorded to the nearest second. There were twice as many from 10 to 12 seconds as they were from 4 to 6 seconds. Complete the table and bar chart using the information. Okay, so let's have a look at this table here. Right, so length of video. So we don't know how many videos were between 1 and 3 seconds or between 4 and 6 seconds, but we know there were 9 between 7 and 9 seconds. We don't know how many between 10 and 12 seconds, and we know there were 6 between 13 and 15 seconds. But remember, they told us there were twice as many from 10 to 12 seconds as there were from 4 to 6. All right, but we don't know either of those. So what can we do? Well, we do have this bar chart down here. Okay, so the 7 to 9 and the 13 to 15 we've already got. The 10 to 12 we can see, if we read across, the frequency is actually 8. Okay, so if we put that there so we can see, we can fill an 8 in there. And now we can go back to the information, which was that there were twice as many 10 to 12 as there were 4 to 6. So twice as many. So it means this one is twice as big as this, or in other words, this is half of this. So we want 8 divided by 2. We'll go through our 2 times table. 2, 4, 6, 8. So that must be 4. Now we know in total there were 30 videos. Well, if we add these all up, this number must be whatever we need to make it up to 30. Okay, so we want to add these all together. Well, in fact, I'm going to do 4, 6, 9, 8. So we're adding them all up, but I'll put the 4 and 6 together because I know 4 plus 6 makes 10. So it's just making the adding a bit easier for me. So 4 and 6 is 10, plus 9 is 19, plus 8 is 27. We know there's 30 in total, so if we've already got 27, 28, 29, 30, there must be 3 in that category. And they asked us to complete the table, which we've done, and the bar chart. So for the bar chart, we haven't got anything for the 1 to 3 category or the 4 to 6. In 1 to 3, we know there were 3. So, well, this is 2. This is 4, so 3 must be halfway between the 2. So we can draw that bar in there. And how many in the 4 to 6 category? We had 4 there. So this time we can go up to 4. And note, I'm keeping the bars the same width as all the others. You don't need to colour it in. They've got their shaded look. I can do that if I want, but you really don't need to. I'd probably say leave them blank, to be honest. But for the video, so it shows up more, I've just shaded them for you. Okay. Coins can be bought on this app. The coins can be used to buy emojis to show approval of videos. This week, there is a 20% discount on coins. Before the discount, 10,000 coins, put my comma in there, 10,000 coins cost £80 before the discount. Work out the total cost of 30,000 coins, after the discount. Right, so we've got the cost for 10,000 coins and we want a discount. 2 ways of doing this. We can discount the £80 first, and then work out how much that would be for 30,000. Or we can work out the total undiscounted cost of 30,000 and then take the discount off afterwards. Doesn't really matter which way you want to do it. I think what I'm going to do is work out. I'm going to take the discount off first. So we've got a 20% discount. Right, well, if it costs £80, we want 20% of £80. So you could do that, 20 divided by 100 times 80. In fact, I had a comment recently saying, why don't I do more calculations like this? Well, I could, but then I sort of I can cancel some zeros and multiply them out. I find it much easier to say, well, I want 20%. I know that 10%, I just take the 0 off. So 10% is just going to be £8. So 20%, well, that's just double. That's just 2 lots of that. And 2 lots of 8 is 16. So the discount is £16. So do the 80 minus 16, or 0 minus 6 you can't do. So reduce the 8 to a 7 and we can make that 10. 10 minus 6 is 4. 7 minus 1 is 6. So it's £64 for 10,000 coins. We want the cost of 30,000 coins. Now hopefully you'll see that we've got the same number of zeros. The only thing that's changing is the first digit. So from 10,000 to 30,000, we're just multiplying by 3. So that means we need to multiply the cost by 3. So 3 times 4, 4, 8, 12. To carry the 1. 3 times 6, 6, 12, 18, add the 1, 19. So we've got a total of £192. (8C). One of Jude's videos receives 60 heart emojis worth 5 coins each and 40 star emojis worth 10 coins each. The app keeps 1/5 of the coins. Jude earns the rest of the coins. Work out the number of coins Jude earns from this video. Right, so 60 emojis worth 5 coins each. So we want 60 times 5. Now I've not written this as a column because I don't need to. I can just say, well, ignore the 0 for now. Do 6 times 5. Or 5 sixes. So 6, 12, 18, 24, 30. And then I just put the 0 on the end. Okay, so that's 300 coins. And 40 emojis worth 10 coins each. Or 40 times 10. Again, I know multiply by 10, I just add a 0 on the end. Okay, so got 300 coins from the heart emojis, 400 coins from the star emojis. Add them together, 0, 0, 7. So we get 700 coins altogether. Now, the app keeps 1/5 of the coins. So we want 700 divided by 5. That's how many coins they keep. So let's do this with the bus stop method. Right, 5 goes into 7 once. 6, 7, so with 2 left over. 5 goes into 20, 5, 10, 15, 20, that's 4 times. 5 into 0, doesn't go. So 140 coins are for the app. So Jude keeps the rest. So in other words, 700 minus the 140 coins that goes to the app. So 0 minus 0 is 0. 0 minus 4 we can't do. So reduce that to a 6. And now we've got 10 minus 4 is 6. 6 minus 1 is 5. So he keeps 560 coins. And that's the end of the non-calculator section. Okay, so now we're on to the calculator section. Okay, question 1. A fair 6-sided dice is rolled. Which letter shows the probability of landing on an even number? Okay, so a 6-sided dice, so we've got 1, 2, 3, 4, 5 or 6. They're the possible outcomes. We're interested in the even numbers, so that's 2, 4 or 6. So in other words, 1, 2, 3 possible numbers out of 1, 2, 3, 4, 5, 6. Okay, 3 out of 6, we can see 3 is half of 6. So that's the same as a half. Okay, so we want somewhere that's halfway. If this is 0, this is 1. Bum, bum, bum. It's going to be C. Okay, question 2. Circle the fraction with the same value as 3 3/4. Right, well, we can think of 3 3/4. We've got 3 wholes. So that's like 4 over 4. So that's 1 whole. That's another whole. That's another whole. So 1, 2, 3. And then we've got 3/4 left. And so because they're all quarters, we can just add up the top. 4 plus 4 is 8, plus 4 is 12, plus 3 is 15. Question 3. Measure the size of angle X. So you really need your protractor for this one. Hopefully what you want to do before you even start measuring it is just kind of almost do a bit of a guess so that we can use that to check our answer. Well, I know that a right angle would be if I had a line going straight up here, that would be a right angle. And that's 90 degrees. This is smaller than that, so it should be less than 90 degrees. So if I put my crosshairs on the corner of the angle, and I've got one line going on the bottom. So I'm starting off down here. So I want to start with the 0, not from the 180 side, because this is the angle we're measuring. So we start here, 0, 10, 20, 30, 40, 50, and 60 is where the line's going through. So our angle is 60 degrees. Question 4. Calculate minus 5 times minus 6. Well, we can use our calculator. Now, with a simple calculator, you need to type the number in first and then the minus sign. So minus 5 times, so then we need to do 6 minus, which is 30. Now, you might also remember that if you've got a minus number times another minus number, they cancel out. Okay, so the only way you'd get a minus answer is if one of them was minus or negative and the other was positive. But if they're both positive or both negative and you're multiplying, the answer is always going to be positive. So we've got our 30 there. Okay, question 5. The front elevation and side elevation of a shape are shown. Here's the front elevation. Here's the side elevation. Which shape has these elevations? Circle the correct answer. Right, let's see if we can have everything in the picture. Okay, so the front elevation. So, well, it's not telling us which is the front and which is the side. But if this is the shape, for example, looking at A, the front's one's going to be this view, most likely, and one's going to be looking at it from this way. What we can certainly see is that these they've got like a column of 3 blocks, and then they've got one sticking out in the middle. A has got a column of 3 blocks, but then it's got one sticking out at the top. So it's definitely not going to be A. If we look at C, C's got one sticking out at the top as well, with the 3 columns. With the 3 blocks in a column. So it can't be C. B looks possible. 1, 2, 3 columns in a row, and we've got one sticking out on both sides. Let's look at D. Well, D hasn't got 3 blocks in a row. It's got 2 on that side, 2 on that side, so it can't be D. So just by a process of elimination, it has to be B. And so if we look at it, well, if we've got one bit sticking out there, so if we were looking at it this way, so this must be our front elevation. So you wouldn't see this one sticking out. You would just see 1, 2, 3 faces there. This one out on the right. And the side, so that's going to be front. Oh, you can't see me writing there, can you? That's front. This must be the side, because from the side you would see 1, 2, 3 blocks there, which is our 1, 2, 3 here, and then this middle one sticking out would be this middle one sticking out there. Question 6. Round 14.76 to 1 decimal place. Well, the first decimal place is the number after the decimal point, but we need to look at the number or the digit after that. And if it's 5 or more, we need to increase that. So instead of a 7, that's going to become an 8. Question 7. Here are 6 numbers. Work out the mean. Well, the mean is the total, or all of them added together, divided by the frequency, or how many. Okay, so we can add these all up. So we can use our calculator. 16 plus 19 plus 16 plus 10 plus 17 plus 12. Get a total of 90. And how many have we got? Well, they tell us it's 6, but we can 1, 2, 3, 4, 5, 6. We can check that. 90 divided by 6. We've got a mean of 15. We can put that down here. Question 8. Increase 630 by 40%. Well, to increase it by 40%, what I'm going to do first is work out 40%. So I'm going to do 40 over 100 times 630. Now, I was saying in the non-calculator section that I'd like to work out 10% first and multiply it up. The reason I do that is because that's the non-calculator section and it's easier to work out 10%. But if I'm doing this with a calculator, then I can go straight for the full calculation. So we can just say 40 divided by 100 times 630, which gives 252. But we want to increase 630 by the 40%. So in other words, it's 630 plus 252, which gives us 882, which we can put on our answer line. Actually, let's have that up here so we can try and see the whole question. And the number of marks, we've got 4 marks. Question 9, the kitchen fitter. Ryan is a kitchen fitter. 9A. A customer wants cupboards along one wall of her kitchen. Ryan can choose from these cupboards. So we've got a large cupboard, which is 600 millimetres across, and a small cupboard, which is 450 millimetres across. He can choose some of each size. The length of the wall is 3.45 metres. How many of each cupboard could Ryan choose so that they fit the length of the wall with no gaps? Okay, so how can we do this? Well, to start with, we've got some measurements in millimetres, but we've got the length of the wall in metres. So we want everything to be in the same units. So I'm going to put everything into millimetres so that we get rid of the decimals. I know that we have 100 centimetres in 1 metre. So actually, if we multiply this by 100, it's going to give me that measurement in centimetres. (345 centimetres). But we want to get to millimetres. And I know that there's 10 millimetres in 1 centimetre. So if I multiply that by 10, I get 3,450 millimetres. Okay, so what we've got to do is work out how can we fit these numbers into this, but without any left over. So we can choose how many 600s we have, how many 450s we have, and it's a bit of trial and error, but hopefully what you'd recognise is that we've got 450 on the end here, and we know that one small one is 450. So if we take that off, so say we do 3,450 minus 450, well, that's just going to leave us with 3,000 millimetres. Okay, and if we do 3,000 millimetres divided by 600 millimetres, so how many large ones can we fit in the remaining space? We get 5. So what that's telling us is that we can have 5 large cupboards and 1 small cupboard. (9B). A different customer wants 3 large cupboards with width 600 millimetres and depth 600 millimetres, so width and the depth, and 2 small cupboards with width 450 millimetres and depth 600 millimetres. So the depth is the same on both, but we've got different widths. The cupboards fit along one wall of this customer's kitchen. The grid on the page opposite shows a scale drawing of the kitchen. The scale is 1 centimetre, represents 150 millimetres. Use the grid to draw a plan of where Ryan could fit the cupboards. Okay, let's have a quick look at our grid. Okay, and we got that 1 centimetre represents 150 millimetres. So if we go back to the question and say, right, instead of millimetres, we want to turn this into squares, or like 1 centimetre squares. So if 1 centimetre represents 150 millimetres, if we divide this by 150, it's going to tell me how many centimetres or how many individual squares we're going to need on the grid. So 600 divided by 150 gives us 4, so we'll say 4 squares. Okay. And so that's going to be the same for the depth. Now for the width, if we divide that by 150, we get 3 squares. Okay, so let's have a look at our grid now. And we needed to fit, and I'm going to write it here, we want 3 large and 2 small. Now they haven't said which wall we need to go along, but we know that actually the large ones, if we draw them here, it was 4 squares across by 4 squares deep, and the small ones were 3 squares across by 4 squares deep. So, and they need to go along one wall. Well, if we've got 3 large and 2 small, it's going to be 3 times 4, because we're going to need 3 of those, and then we need 2 of these ones, so it's going to be 2 times 3. Well, 3 times 4, we can do that on the calculator. You probably don't need to, but 3 times 4 is 12, and 2 times 3 is 6. So if we add those together, we get 18. So we need 18 squares along one wall. Well, if we pick this wall, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it's not going to be enough. So probably going to have to be, well, this wall or this wall, it doesn't matter left or right. But let's count them. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to write 10 there. Let's move it down. 11, 12, 13, 14, 15, 16, 17, 18. Right. So we're going to need all 18 of those. They haven't said what order we need them. So maybe if I do my large ones first. So if they're on this wall, the front of the cupboard's going to be here. I'm going to be looking at them this way. They're 4 squares deep. So 1, 2, 3, 4. So the front of the cupboard's going to be here. And the large cupboards are 4 squares wide. So 1, 2, 3, 4. So that's going to be a large cupboard. And we need 3 of them like that. So 1, 2, 3, 4. We can do another one here. That's another large one. Another one that's large. 1, 2, 3, 4. And then we've got the 2 small cupboards, which are both 3 wide. So 1, 2, 3. So that's a small one. Oh, I did that off the page, sorry. And 1, 2, 3. Another small one down there. Okay, so that's all of them fitted on. 2 small, 1, 2, 3 large, all along the same wall, all the same depth, but with different widths. You don't have to do them in this. You don't have to do them in this order. You could have small at the top, or large, small, or whatever you want to do, as long as you've got the 5 of them all fitted in. Okay. 9C. This is the price list for Ryan's kitchen cupboards. A large cupboard is £85.50 per cupboard, and a small cupboard is £75 per cupboard. There's a special offer. Large cupboards, buy one, get one half price. A customer wants to order 6 large cupboards and 2 small cupboards. The customer has a budget of £550. Does the customer have enough money to buy these cupboards? And if you move it down, we can see we've got 5 marks here. So roughly 5 things that we're going to have to do. Right, so let's think about how much these are all going to cost. So 6 large cupboards and 2 small cupboards. Well, there's 2 small ones are going to be easy. We're just going to multiply that by 2. So let's do that first. Get that done. £150. Now 6 large cupboards, but you buy one, get one half price. So think of that as we buy one, then we get one half price. Buy one, get one half price. So that's like the first cupboard, the second, third, fourth, fifth, and sixth. So we've bought 4 so far. The 5th one we have to pay full price for the 5th, but then the 6th one we pay half price. So if we add these up, we've got 1, 2, 3, half and half makes 4 and a half. So we're only paying for 4 and a half or 4.5 large cupboards. Okay, we're getting 6, but because of the discount, we're only paying for 4 and a half. So we've got 4 and a half at £85.50 each. Which is £384.75. So we take the cost of the large ones, add it on to the cost of the small ones. We get £534.75. The customer has a budget of £550. Well, £550 is more than £534.75. So do they have enough? Yes. Or we can put it down here. Yes. They have enough. Question 10. Flower farm. Eric grows daffodils on his farm. 10A. This is a sketch of a field where Eric will grow daffodils. Actually, we don't need to have that picture of daffodils anymore. Okay. So we've got some of the measurements of the field on here. Eric plants 1.25 kilograms of daffodil bulbs per square metre of land. He has 20 tonnes of bulbs. And we're told that 1 tonne is 1,000 kilograms. I'll put my column in there. Does Eric have enough bulbs to plant all of this field? You must show your working. Right, so we've got to work out the area of this field. I don't have to do that first, but I'm going to do that as a starting point. And to do that, I'm going to split this field into rectangles. So I'm going to draw a line straight down here. So the area of this rectangle, it's the length times the width, so it's going to be 150 times 84. So 12,600. And that's going to be in metres squared. And this rectangle here, well, the length, well, we haven't got this length at the moment. We've got this length, but we haven't got this bit. Well, this length is going to be the full length, so it's going to be the 223 all the way across, but without the first bit, so minus 150. So 223 minus 150 gives us 73 metres. So the area here is going to be 73 times 60, the distance there, which gives us 4,380 metres squared. So our total area is going to be 12,600 plus 4,380, which is 16,980 metres squared. But that's not all we have to do. We need to work out how many daffodil bulbs are going to fit in there. So Eric plants 1.25 kilograms of daffodil bulbs per square metre. So if we multiply this by 1.25, it's going to tell us how many kilograms of bulbs he's planting. So we have got, that doesn't look right. What did I do? I didn't do something right. We have 16,980 meters squared. Multiply it by 1.25. Yeah, that looks better. I'm not sure what I typed in. 225. And that is going to be kilograms of bulbs. Now, you might be thinking, oh, but I just got a crazy answer there that wasn't right. But what I noticed was the answer I had was smaller than the number I started with. So if I'm multiplying it by something more than 1, if my answer's not bigger, then I know something's gone wrong. So don't just blindly type things into your calculator. Look at what you're doing as well, so that, like I just did, and I say I don't know what mistake I made, but I clearly made one, so I could just go back, type the numbers in again, and get something that looks more sensible. Okay. Right, so he needs to plant 21,225 kilograms. He's got 20 tons of bulbs. If 1 ton is 1,000 kilograms, we want 20 lots of that. Which is 20,000. Okay, so he's got 20,000 kilograms. He needs 21,225 kilograms. So has he got enough? No, not enough. (10B). Joe picks flowers on Eric's farm. Joe is paid £8.29p for each box he fills with flowers. The flower picking season lasts for 10 weeks. The list shows the number of boxes Joe filled each week for the first 5 weeks. Estimate how much Joe can expect to earn for the full 10-week season. You must show your working. Okay, so what we can do is we can work out how much he got paid for this first 5 weeks. And 10 weeks, well, 10 weeks is double 5. So we can just double our answer. So if we add these together, this will tell us how many boxes he filled. So 55 plus 47 plus 45 plus 44 plus 59, 250 boxes. And well, actually, we could multiply that by the cost, or we can say, well, if that's for 5 weeks, 10 weeks, we'll multiply it by 2. So we can do this multiplication first. So we're saying 500 boxes for 10 weeks. Okay, so if it's 500 boxes and he gets paid £8.29 for each box, we multiply them together, 500 times £8.29, and we get £4,145. Eric plants different types of daffodils in his fields. Here is some data about the area he planted with each type of daffodil. So a golden ducat, he planted 88,000 metres squared, so I'm going to put my commas in here. White line, 72,000 metres of those. Ice follies, 46,000 metres, and pink pride, 34,000 metres. Draw a suitable chart to show this data. Well, we're showing individual things, so I'm going to go with a bar chart. I think that's going to be the easiest. And we've got 4 different categories. So I'm going to see how I can split this table up into 4 equally spaced bars. How should we do this? Well, I'm going to start, maybe if I start in this corner here, so I can write on the graph paper. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's quite hard to see the different lines on here, but you should notice there's some slightly darker lines. I think it would show up more on the original graph paper. But we had 12 boxes across, and we've got 4 categories. So that means we want 3 boxes for each category. So that's 1, 2, 3. 1, 2, 3. 1, 2. Got this hard. 1, 2, 3, 4, 3. And then 1, 2, 3 takes me up to the end. So this is difficult on this graph paper, but I'm pretty sure it'll be clearer in the exam. Okay, so these are going to be my type of daffodil. Daffodil. Can I spell daffodil properly? Now I can. And on the bottom, so this first category was golden ducat. I've never heard of any of these, by the way. Then a white lion. Then ice follies. And pink pride. I don't think I've ever seen a pink daffodil. Okay, now we've got to go for the scale up the other side. So we look for the biggest number, and that's the 88,000. All right, so, well, it's thousands, so let's forget the thousands. Let's just think 88 for now, and we can do our units in thousands. So how many boxes have we got? We've got 1, 2, 3. And when I say boxes, I say they're sort of split into these 5 by 5 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this could be 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. Now for area planted, they've done it in meters squared, but we can say meters squared or 1,000 meters squared. Okay. If you want, you can write 90,000. You could put the zeros on, but I'll put it in my units here instead, which would be absolutely fine. Now we've just got to plot them. So the golden ducats were 88,000. Here's 80,000, here's 90,000. We're going up 2s, so because we've only got 5 squares, so it must be 82, 84, 86, 88, 90. So the way I'm working that out is I'm saying, well, I've got a difference of 10,000 between 80 and 90. 10,000, but I've only got 5 squares to split them across. So each little square must be worth 2. So that's what I'm saying, 82, 84, 86, 88 must be along there. Then I can draw my line down. And then we've got white lions next, 72,000. And no, I'm not reordering these, I'm putting them exactly in the order that they've given them. So 70,000's here, so 72 must be the next box up. So that's that one. Draw my line. Then we've got ice follies. Ice follies, we've got 46,000 of those. So here's the 40,000. So 42, 44, 46 is going to be here. Where's that? It is tricky on this graph paper, so we've just got to be extra careful. And finally, pink pride, we've got 34,000 of those. So here's 30,000. So 32, 34. Okay, and all we need is a title. I'm just going to call them daffodils. That's enough. Or types of daffodil, whatever you want. Okay, question 11. Parcels. Sam sends parcels using couriers. 11a. The table shows information about the cost of sending parcels with Go Parcels. We don't need that picture anymore, so we'll move that up there. We've got the cost depends on the weight. So anything up to 1 kilogram costs £5.99. If it's more than a kilogram, but up to 10 kilograms, it costs £12.99. If it's more than 10 kilograms, but up to 15 kilograms, for example, 14 kilograms would be in here, would cost £14.24. And anything more than 15 kilograms, but up to 20 kilograms, costs £25.49p. Sam needs to send items weighing 2 kilograms, 4 kilograms and 11 kilograms. Sam can combine the 3 items into one parcel before sending. How much cheaper is it to send one combined parcel rather than 3 separate parcels? Okay, well, if they do 3 separate parcels, we've got a 2 kilogram, which would be in this category, so we'd have £12.99. A 4 kilogram, which would be another one in that category, and an 11 kilogram, which would fit in here. So let's work out that total. So £12.99 plus another £12.99 plus £14.24 is £40.22p. Now if we combine them, well, 2 plus 4 plus 11 is 17 kilograms. And if it was 17 kilograms, well, that would fall into this category between 15 and 20. So that would cost £25.49. They want to know how much cheaper it is. So in other words, it's the difference. It's the £40.22 minus the £25.49 that we'd actually have to pay. So 40.22 minus 25.49 means we would save £14.73p. So well worth combining. 11b. Sam sends a parcel with a different courier, Package Plus. The parcel is a cuboid measuring 2 meters by 0.4 meters by 0.6 meters. And here's a picture of it. Okay. Package Plus charges using the formula, and the cost is a fixed £15.25p plus the volume of the parcel in meters cubed times by £4.25p. Sam pays with a £20 note. How much change should Sam receive? Right, well, we need to work out the volume of the parcel in meters first of all. That's the missing bit. Well, the volume is equal to the length times the width times the height. And they want it all in meters, which is fine. That's what we've got. So we need 2 times 0.4 times 0.6, which gives us 0.48 meters cubed. So if we put that into the formula, we've got £15.25. We haven't done anything with that. The volume of the parcel, so 0.48 times £4.25. And we can leave the brackets in to show that needs to be done first. So, still got £15.25 because we haven't done anything with that, but we need to do this multiplication. So 0.48 times 4.25 p, which gives 2.04. If we add that on to £15.25, we get £17.29p. He pays with a £20 note. How much change will he get? So it's going to be 20 minus 17.29, which gives us £2.71. Question 12. The theatre. Amy is going to a theatre show in Chichester. Amy will travel by train to Chichester. Amy has a rail card that gives her 1/3 off the normal price of a train ticket. The normal price of a train ticket to Chichester is £16.83. Amy says, my ticket will cost less than £11 if I use my rail card. Is Amy correct? Okay, well, what we can do is we can work out 1/3 of the ticket and take it off the price. But we can do a bit of a shortcut. Because if it's 1/3 off the price, well, that means she's only going to pay for 2/3 of the price. So we can just go straight in with 2/3 of £16.83. Okay. 16.83. Okay, which is going to be £12 to 1. We've got a 9 to round it up to £12.22. Okay. Oh, sorry, not 12. It's 11, isn't it? I misread that. £11.22. Okay. Well, that's more than £11. So is Amy correct? No, she's not. So if you want, you can work out 1/3 of the price and then take it away. Let's say this is a slightly quicker way. Instead of doing 2 steps, you're just working out 2/3 and you get straight to your answer. (12B). The theatre sells ice creams at the interval. All the ice creams cost the same amount. Amy buys herself and her 2 friends an ice cream each. The total cost is £8.40. How much does it cost to buy 7 ice creams? Right, well, Amy buys herself and her 2 friends. So that's 1 for her, 2 for the friends. So that's 3 altogether for £8.40. So 1 ice cream must be £8.40 divided by 3. Which is £2.80 because it's money, so it can't have just 2.8, £2.80 each. If we want 7 of them, we'll multiply it by 7, which gives us 19.6, but because it's money, it's going to be £19.60. At the theatre, the show starts at 7:30 p.m. The show lasts for 150 minutes, plus a 20-minute interval. At the end of the show, it will take Amy 35 minutes to get to the station. A train leaves the station at 22:17. Can Amy catch this train? Right, you must show you're working. So starting at 7:30, so how long's all of this stuff going to take? Well, we've got 150 minutes, plus a 20-minute interval, plus 35 minutes to get to the station. 105 plus 20 plus 35, so that's 160 minutes. Okay, so what we can do is say, well, what is that in hours and minutes? And probably the easiest way to do it is to just take off 60 minutes for each hour. So take off 60, we're left with 100 minutes. Take off another 60, we're left with 40 minutes. So 160 minutes is the same as 2 hours, 40 minutes. Right, so we're starting at 7:30. We want to go on 2 hours and 40 minutes. Well, if we add on just 2 hours to start with, do the easy bit. That's going to take us up to 9:30 p.m. Then we want to add on 40 minutes. But let's make it easier. And let's say, well, to go from 9:30 to the next hour, so to take us up to 10 o'clock, it's just going to be another 30 minutes, isn't it? It's going to be half an hour. Okay, but we've got 40 minutes. If we only have used 30, we've still got 10 minutes left to add on. So 10 o'clock, or 10 p.m. plus 10 minutes is going to be 10 p.m. Right, a train leaves the station at 22:17. So we've got to go from either 24-hour clock to 12-hour clock or the other way round. Let's go from this. So if we want to turn this into a 24-hour clock, we just need to add 12 hours to it. So 10 plus 12 is going to make this 22:10. And we don't need the PM anymore because it's now a 24-hour clock. And 22:10 is before 22:17. So can Amy catch this train? Yes. She can catch the train. And the final part on this paper. Jai works in the box office at the theatre. The theatre has 1,206 seats. For this performance, the ratio of tickets sold to tickets not sold is 5:1. So for every 5 tickets they sold, there was 1 ticket not sold. Jai says, we've sold more than 1,000 tickets for this performance. Show that he is correct. Right, ratio question. So let's draw a little ratio table. And we're going to have sold, not sold, and we're going to have a total column. And the ratio of sold to not sold is 5:1. And if that's all we had, 5 tickets sold and 1 not sold, we'd have 6 in total. But they're telling us there's 1,206 in total. So we can see, well, how many times of this first row go into this one? So in other words, we want 1,206 divided by 6. And that's 201. So we're saying we're multiplying by 201 to get from 6 to 1,206. So 201 lots of these. So we just need to do the same with the other columns, multiply them by 201. So for the not sold, it's easy. 1 times 201, just be 201. And for the sold column, multiply by 5, we get 1,005. Well, 1,005 is more than 1,000, so we've shown that he's correct. So thank you for watching. Hope you found the video useful. Please give me a thumbs up, like the video, subscribe to the channel, have your notifications on to find out when I upload more videos, and look forward to seeing you again soon. Thank you.